we are filming.
Have you seen like doctors handwriting? They're the worst. Their signature.
It's rare.
It's literally chicken scratch.
It's somebody takes their arm and stomps on it while they hold the pen. But yeah. Anyway, let us pray. Use the cheat sheet if you must. In nomine Patris et Filii et Spiritus Sancti. Amen. Sancta Michael Arcangelo, defende nos, prego, contra nequitiam et insidias diaboli, est presidio. Impere illi Deus, supplicens te pregam, tuque princeps militiae celestis, Satanam, aliosque spiritus malignos, quia perditionem animalem pervigantur in mundo, divina virtutem in infernum detruit. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. Alrighty, we're looking at homework 1G, as in goat, looking at some charts and such. And let me see what you got. And for those of you listening at home, hi Isaiah. This is the one that's coming up for tomorrow is homework 1H, as in Harold, and I believe that may be the last
Before the test.
homework before the test. I'm still there, I'm just off screen.
I thought 1H. We have one more.
Yeah, 1H is going to be the last, and that we'll be doing Monday. Introduction to functions.
We
So,
might have a test or like that.
next week sometime we're going to have a test. So, what should I got? So basically 8 through 20.
I don't know where it went.
Okay, and
I'll get it to you on Monday.
we'll talk about it. All right. The answers are as follows. I might be off screen. Hang on a second.
It's right where the your cuts off the Y on the.
Okay. I don't know who you are. Okay. Over here.
Yeah,
Yeah,
it
you
cuts off
can't.
the Y.
Yeah, you
Okay.
can't go over
Got it.
like sake. You can see
Okay.
sake.
I'm back on screen. Hi. So let's take a look. Number 8. As the years of education increase, the average salary, these are all true or false. As the years of education increase, the average salary increases. True. Number 9, false. Number 10, true. So true, false, true for 8, 9, and 10. Grab my iPod. Any repeats so far? Okay. Number 11. That's better. Make a bar graph of the data. Excuse me. For pity's sake. See additional answers beginning on page AA1.
I need it. So much better. I only have
Got
a
it.
notebook like that.
You have a notebook that's like this.
Yeah.
You should use the notebook.
Got it.
I know, but I didn't bring it.
So there should be 5 bars. Basically you should have the water going from 0 to about 120-ish, and you should have 5 entries on the food. Should lettuce, tomatoes, melons, broccoli, corn. Lettuce should be about, depending on what you count by. I counted by tens, but I made mine kind of tall. So the first one should go up a little past 20. Lettuce. The tomatoes should be a teeny bit less than 30 height-wise. Melons should be exactly 40. Broccoli a teeny bit over 40, and corn just a little bit under 120. Makes sense? Okay. And I lost it. Here it is. All right, number 12. How many millions of tons of waste were generated? Oh, sorry. What was the most common waste? It was paper. And how many tons? Roughly 80 million tons. Do keep in mind at the bottom of the chart it said millions of tons. So it's not just 80, but 80 million. And blue is generated and green is recycled. Which kind of waste had the greatest amount recycled? Paper. And then how much was recycled? About 33 million. Hopefully we get better than that right now. That was in 1995. Number 14. What kind of waste had the least amount recycled? Plastics. million or something like that. So less than, anywhere between 0 and 3, I would accept. All right, number 15. For how many years did the minimum wage remain the same? 6 years. What was the minimum wage during the time when it remained the same? Roughly $4.25 an hour. And in which year did the minimum wage increase to over $4? That was in 1991. Number 18. Make a line graph of the data and discuss what it shows. It pretty much goes steadily up. It goes up, slows down a little bit, then goes up, up. Basically, the number of television stations increased consistently. So it kept increasing pretty steadily. So if they say discuss what the line graph shows, it shows that the number of TV stations kept growing pretty constantly. Number 19, passenger car fuel efficiency. Make a line graph. You should have, starting from 1980, somewhere around a little over 24, then it kind of jumps way up and then flattens off. So what does it say there? Discuss that? No, it doesn't either. Just make the graph. Number 20. From 1991 to 1996, which type of recording showed an increase in the number sold? CDs. Wow, is this an old book? They still make them, but you've all seen a cassette tape? Okay. Have you seen like old-fashioned albums? Like
Yes, I love
record player album? My mom still has some of those.
Oh, they're great.
They came in all sorts of sizes. They're like 45s and 33s and 78s. It was interesting. But yeah, you can find them at St. Vincent de Paul. Pretty much any place you can find them on the internet. So an increase was in CDs, which showed a decrease cassettes, which remained about the same albums, probably because they weren't buying many anymore. In which 2 years did the total number of all types of recordings remain about the same? 1995 and 1996. They pretty much stabilized. Compare the usefulness of the two graphs. I would say the left-hand one is way more useful. The right-hand one is good for doing a total. The left-hand one is good for comparing individuals. So in other words, you want to see how much, how do albums compare to cassettes? The one on the right. Number 21, the graphs show the same data. Write a statement supported by one graph but not the other. In other words, they're trying to say the number of employees. This is actually one of the ways. There's a book called How to Lie with Statistics. It's kind of, I'm actually getting into a little bit of the sampling of that today. Statistics is a way of gathering data and giving it to people and saying what it means. But statistics can be used to deceive. They can be used to lie. And you see the graph on the left-hand side of 21? It looks kind of flat, and the one on the right looks really kind of steep. It's going up, 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 up. That's the exact same numbers. You notice on the left-hand one, they counted by something really fast. In other words, that makes the thing look flat. Like if they're counting by 200s, which crushes everything. And on the other side, they're counting by 25s, which zooms in and makes it look a lot better. If I were somebody who wanted to make this company look good, which one of those would I choose? The left or the right?
Probably
The right. And they said, wow, we're getting lots of employees, woohoo. If I wanted to make the company look bad, which one would I choose? The left. Look what our competitor's doing. They're not getting anybody. It's itty bitty little bit of new employees. See? So it's the exact same data, but you can use it to twist people's minds about it. Righty. And it was 8 through 20. Oh, I didn't have to do 21. Went off a cliff, I kept going. Any questions? How'd that go? What's that? Oh, thank you.
Just screwing it over again in 8 in my favor.
Oh dear. Any repeats, first of all? Questions? Anything you want to see dissected or feeling pretty good on it? Okay. Alrighty, let's launch ahead to the last section. Check out your notes, please. I would like to talk about something called a function. Function. I'm going to scoot this thing up a little bit.
Oh no, we're doing inputs and outputs.
Yeah. A
Like,
function.
yeah.
Here's how it's written. This is an example. F parentheses x equals x squared plus 5. What does that mean? In the past, there are lots of ways to show that you multiply. Let's say, here's one way to show that you're multiplying. This is an old-fashioned way. The 2 and then the little x, and then the 3, that's the old-fashioned one. We are not going to use this in algebra. Any idea why not?
Because it looks like that.
It looks like an x, and we use x as a lot. So it looks like 2x3 instead of 2 times 3. Somebody know another way? What's another way to show multiplication?
2, and then 3 in parentheses.
Yeah, so 2 in parentheses, 3 in parentheses. If you put things in parentheses and mush them together, that means multiply. What's another way?
A little dot.
A little dot. Yeah.
Little, like, floating
All of them
period.
have, yeah, like halfway up, halfway down. Yeah, the one danger on this, make sure you don't make it too low, otherwise it looks like 2.3. I have done that on some of my answer keys, which is kind of embarrassing. And then I photocopied the answer keys for everybody. It's 2.3. You could also do this. Those are legal. They're a little weird. These are only legal with 2 variables or 2 numbers, not one of each. I'll show you why not. Down here, if you have one number and one letter, that's another way to show multiplying. You just squeeze them together. This is only with a number followed by a variable. In other words, up here, if I had done this, x3, that would not be allowed. If I did this, that would not be allowed. In other words, if you have one of each, they don't like that. If you have one of each, you can actually cram them together, but just make sure the number's in front. They call it the coefficient. So in other words, x2, oops, you're on the wrong side. X2 would not be acceptable. Part of the reason for that is it looks like, if you write it sloppily, it looks like x squared. Yeah. So they want to make sure that the number is in front so it's not confuse you. So these are the acceptable ways to show multiplication. This looks, let me see. Actually, I'm going to take one thing back. Only with 2 variables, or if the variable is may put a little, have you ever seen this in a book where you put a little star by here, where there's a note somewhere else? Do that here. Do a little, here, I'll show you. Two variables. Only if the first variable is in parentheses. In other words, if I had this is good. If I have this is bad. It seems a little complicated, so why all these weird rules?
Do we have to use it that way, or can we just, do we have to write it like?
You do not.
Okay.
I actually avoid this, just
Okay.
because I can't.
Because like it's already too complicated.
This would be
It's like-
annoying, yeah, this is annoying for me to remember. So basically I had to stick to these. So I actually kind of just, like for number variables, I use this. And I use this a lot, and this a lot. I like, here are the ones I like the best. This one, and this one. All the other ones kind of, a whole bunch of rules to remember that I really don't want to remember.
What's the rule on the last one?
I'm sorry?
The last one?
I think that was it.
No, what's the one with the very last one? The 2x?
Oh. This thing here?
The other one?
This thing?
Nope. To the left.
Here.
Down.
Here.
That.
Okay. So only, yeah, this is only with a number followed by a variable. That's the only version.
Okay.
Yeah. So don't switch it around. Now, one thing I do want to remember, again, why are there so many weird rules? Because hundreds of years ago, when people were inventing math symbols, there's a group of math people in Germany that invented their own symbols, because they really didn't talk much to people in France and Russia and what have you. And then the people in France made their own symbols, and then the people in Russia made their own symbols, and the people in the Middle East made their own symbols, and they're all different. So by the time the mathematicians started talking to each other, they actually started arguing with each other over whose symbol should be used worldwide. Ours is the best. No, ours is the best. No, you're an idiot. I'm the, etc. This is actually true. There were like nasty letters written back and forth to see if like our symbol makes the most sense. No, you don't know what you're talking about. Blah blah blah. It took a long time to decide which symbols were going to be used for what, and sometimes they just used both, which was, even though both of them were kind of, seriously. I'll show you an example of that next chapter. But there's a time where a symbol for one thing and a symbol for something else looked almost identical. And you just have to look really carefully and just recognize, oh, in this situation it means this. Pain in the neck. But hundreds of years ago, it's better than starting a war. So, all right. If you have a variable in front without parentheses, followed by a variable with parentheses, that is a function. They set that aside. It's like whenever you have a regular letter followed by a parentheses letter, that will always mean a function. So let me write this again. It's f parentheses x equals x squared plus 5. What does this mean? Here's how you say it in English. F of x equals x squared plus 5. F of x. F of x. And why? It's actually short for something.
F times F.
It's short for, it's actually not.
No.
This is one of the times where it's not, because they forbade it. And even letters, they forbade it. Like here, they forbade it. And this is the reason. It's short for function of x. They say f of x because it's short for function of x. But what does it mean?
You can only.
I can go this far?
Yeah.
I hope I can go this far. So, Isaiah, if I go off screen, I apologize profusely.
You just
So-
can't go past save to the left. can't go
this?
left to save.
You can see.
Oh, okay. I'll just try and be
To the,
squeak, other, like, here, maybe.
Yeah.
Okay.
Oh, he actually went off screen a little bit over there. Oops.
Oh, alright, we're fine, we're fine.
It'll be fine. It's nothing
Yeah,
important.
but that's the stuff we don't wanna do anyway, so.
Yeah,
I'll maybe do a panoramic at the end. So what is this? The letter F, go ahead and write this down, this is key. This is sort of background. This is the actual substance of the lesson. F is the function name. The name of the function is F. The letter inside the parentheses is called the input variable. It's where you plug in. So a function is kind of like a number machine. You plug a number in, crunch, 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 and out comes the answer. And then this stuff over here, is called the output format. Okay. So F is the function name. So you would either call it F or F of X. F for short, F of X for long. Okay. So if I say, what function is this? It's function F, or F of X. What's the input variable? You tell me, what's the input variable? X. What's the output formula, Jenny?
X squared plus 5.
Exactly, X squared plus 5. Now how does it work? Let's find out. Okay. This is the second one. Somebody got this? So careful. The thing's gonna fall.
Yeah, I
is it?
know. And then, like, you can just pause it and grab those notes later. There we go.
Okay, thank you. So here's what it looks like. Let's try this. F of X equals X squared plus 5. And by the way, it doesn't have to be X squared plus 5. I can make a different function if I wanted. What does this mean? Can anybody tell me what's different about that top one? Yeah, it's F. They're the same. What's different? What?
The 10, X,
The X has been replaced with what? 10. That's what they want you to do. In other words, you read this as F of 10. Basically, you plug 10 in for X. Wherever you see an X, replace it with a 10. But I would say use parentheses when plugging in. It keeps it neat, and it actually avoids a lot of math errors. I would strongly recommend use parentheses whenever you plug something in. Here's what I do. Again, when I make up an answer key, and I want to make sure I don't get it wrong, because getting an answer key wrong is really awkward, especially after you grade the entire tests, the entire class's tests, and then you realize your answer key is wrong. And so you marked like 8 million problems wrong that shouldn't have been wrong, and I have to go in with whiteout. And I did that on a final exam once. Like, I had the grades recorded. I was all done, and then I realized I had a really serious mistake on the answer key. I used up 2 bottles of whiteout, whiting out all the red marks that I put on all 25 papers, and then emailing the people, can you please change the grades? Here's what I do now. Parentheses squared plus 5. It's sort of like a slot where you can just plug in the number you want. What number am I going to plug that in? Jimmy, what do you think? What if I replaced X with? In this particular case. Like here, they're saying, use X here. What am I going to use here? 10. To get the answer, plug in a 10 in place of X, wherever you see X. Can somebody calculate this for me? Order of operations, what do you do first?
10 times 2.
Yeah, why that and not addition? Yeah, parentheses, exponents, multiply, divide, add, subtract. So what is 10 squared? What's that?
Really?
100. Now add the 5.
105.
Yeah, your answer is 105. Does that make sense? Let's try another one. F of negative 3. Okay, try this one. What am I plugging in this time? In place of x.
-3.
Negative 3. It's a separate problem. So I'm going to do parentheses squared plus 5. And in the parentheses, the slot, the plug-in slot, I'm going to put negative 3. What's negative 3 squared?
9.
9. Positive or negative?
Positive.
Excellent. Why? Why is it positive and not
Because
negative?
negative times negative makes positive.
Yes. Negative times negative is positive. And what's your final answer? After you add the 5.
14.
14. That's a lot of homework. So if they give you a formula and they say plug in a number, that's up there. Does that make sense? So far? Righty. We're talking a teeny bit about a few things. There are two kind of important words when dealing with a function. We sort of touch them here. Input and output. And there are two fancy words that I'd like you to know. Domain and range. Both of them can be defined by 3 words each, different words. The domain is all legal inputs. It's the collection of all numbers you can legally plug in.
Would be the absolute range.
Good guess. It's not a lot of people think all illegal inputs. Good guess, but it's actually they changed the last word. Yeah, all legal outputs for range. So domain is all the numbers that you could plug in, and range is all the numbers you could get out. So here, the only, well, for example, it's relatively easy once you see the trick. Have you ever seen one of these? It was an XY chart. It's where you have a bunch of x's and then you figure out the y's. Let's just say y is equal to x squared. This is an example. I'm going to go 1, 2, 3, 4. Can somebody give me the y's using this? How would you find it?
2.
Was that?
The first one wouldn't be 2.
Multiply.
1 times 1 is 1.
1 times 1 is 1, correct. So 1 squared is 1. Jenny, get in the next one. Plug in a 2 for x. What would the y be?
4.
Yeah, 2 squared, which in this case is 4. Yeah, what's 3 squared? 9. And then Jenny, what's 4 squared?
16.
Got it. So you notice I had 4 inputs, 1, 2, 3, 4, and 4 outputs, 1, 4, 9, 16. If I ask, what's the domain? It's 1, 2, 3, 4. In other words, all the inputs you used. And then what's the range? Tell me. Anyway.
1, 4, 9, 6,
Yeah.
16.
1, 4, 9, 16. Good. Later on, we'll show you different problems where an input might be illegal. There is a particular thing that you're not supposed to do in math. There are several, but one of them is really, really famous. You can never ever divide by a particular number. You know what it is? It's completely and totally illegal in any branch of math whatsoever. You can never ever ever divide by this one particular number. Take a guess. No death penalty if you're wrong.
That number should become my new favorite number.
1.
You can divide by 1. It's actually kind of boring when that happens, but yeah, like 5 divided by 1 is 5. You can do it, it's just, nothing exciting. There's one that if you try to divide by it, it's incredibly exciting. It's kind of the mathematical equivalent of a bomb going off. Like a nuclear bomb, it just vaporizes everything. Because that was a little dramatic, but what? Zero. You can never divide by 0. Ever, ever, ever. I want to show you why. Do you remember, it was like 3 or 4 years ago? 5 years, who knows? Do you remember how to check division problems? Like 10 divided by 2 is equal to 5. First of all, does everybody agree? Hopefully that's right.
Yeah.
How do you check your answer?
5 times
Yeah,
5,
you
5 times
multiply these and get back up here. Does that make sense? Do you see that from years past? Okay, try this. Go back and check your answer. 0 times something is 10. You tell me. What number multiplied by 0 will give you 10? Absolutely nothing. It's impossible. You can't do it. So that is really, really not right. So dividing by 0, actually I'll show you an even worse one. 0 divided by 0. Multiply. 0 times what is 0? 0 works. Hey, wait a minute, I thought it was illegal. Try the number 1. Does that work? What's 0 times 1?
2.
Oh dear. That works as well. How about 2? 2.5? 7? 1,000? In other words, everything works. It's kind of like, what? You're supposed to have one answer. Like, 88 billion. Let's just say you want to eat one thing. So like, I just want to eat dinner. I've got 5 million dinners coming to you tonight. I can't eat all this. I'm going to explode. Well, somebody's got to pay for this. No, I'm not. I'm not ordering this. You know, there's dividing by 0 doesn't ever give you an answer. It's impossible. Later on when we talk about something called graphing lines and things like that, when you try and graph something divided by 0, it's pretty dramatic. The graph, it's kind of funny actually. I don't know if you've seen graphs like this. Maybe like y equals x and the graph looks like this. If you didn't, don't worry about it. We're going to go over it this year, like a chapter or 2 from that. But if you try and do something where you divide by 0, like 2 over x, guess what value of x I'm not plugging into that thing? Like I can plug in 1, 2 divided by 1 is okay. Guess what number I would never plug in for x? 0. The graph is actually kind of humorous. It looks like this. Like here's x equals 0. Like right, you remember a graph where 2 comma 3, 3 comma 1, this sort of stuff. So here's where x is equal to 0. The graph runs for its life and doesn't hit 0. It's supposed to go straight through. It's supposed to be able to like height of 2. It's like, you're not creating it. It's like this 1 trillion billion volt electric fence. And this that from the other side too. It's like, oh no you don't. And it swerves for its life. It's actually kind of funny. But everything avoids dividing by 0. Like this thing, it says like, if I crash into the divide by 0, I'm going to fry myself. So no, not so much. Does that make sense? Okay, back to homework. Turn please to page 49 in your book. This is where the homework first starts. This is homework 1H as it heralded. For those of you following at home. Page 49. Oh yeah, probably off screen. Sorry, I'll actually let you see my face. So, bottom of page 49, problem number 10. Now, there's one last thing I got to put in your notes. So, scoot your notes out for just a second. There's one concrete rule that we need to follow. First of all, the domain and range, you know what they are. But what is a function? A true function one input yields one output, that is huge. If I were to say, what's the definition of a function? One input yields one output. What that really means is that I don't care what number you plug in. If you plug in a single number, you should get a single answer. You should not get 2 or 3 answers at the same time. Just one to a customer. One input will yield one output. In other words, here's a good example. In the in and the out. If I plug in a 2 and I get out a 5. Think of any numbers you want, I don't care. Here's bad. I plug in a 2 and I get out both 5 and 3. That's bad. Let me give you an example.
Number 12.
Y'all been to, maybe. Have you ever shopped at Aldi? It kind of it's a grocery store. The reason I choose Aldi is because in order to keep the prices down, they don't have brands and brands and brands. Usually they just have this one sort of generic type of, let's just pick something like cream corn. So you've got cans of cream corn, they're all the same size, they're all the same brand. So I go in there and I buy a bunch of cream corn. And I think they're like 49 cents each. And they have the electric scanners just like always. And here's what usually happens. I get a case of like 12 cans of cream corn. And then she sends it through. And she goes, beep, 49, beep, 49, beep, 49, beep, 49. Unless she knows how to do the cash register. 12 times 49, which is faster. But let's just say she just scans it. What would happen if I walked in, got remember, they're all the same brand, all the same size. And then she starts scanning, beep, 49, beep, $1.19, beep, $27.58, beep, $3.84. Hold it. And the cashier says, what? Something's wrong here. What? You tell me, what's wrong?
Is it calculating it?
Mm-mm. It's just giving 4 or 5 different prices for the exact same thing. Is that good? Heck no, that's bad. You just charged me like $27 for the 1 can of cream corn, and 49 cents for that can of cream corn, and $3.85 for that can of cream. They're all the same. If they're all the same type of can, what should be true about the prices?
They're all the same.
They should be all the same price. So if you plug in the same thing lots of times, and you get a bunch of different answers, there's a word for that, and they actually stole it from algebra. And if you go into Aldi and you look at their cash register, and the cash register is going, so let's just say here's a table with X and Y. So here's, item number 1 is 49 cents. Cream corn. I don't know when I did cream corn. And you can do anything you want. It's just, my brain just seized on cream corn. So let's just say item number 1, item number 1, item number 1, item number 1. What should be the output for every single one of these? 49. 0.49, 0.49. So in other words, if you repeat the input, the output better repeat. That's a well-functioning cash register. Now, here's the bad. X and Y. Let's do 5 cans of cream corn. 49, $1.19, $24.95, $3.64, and then 88 cents. Like, what the heck? Oh, is it off screen?
A little bit.
Okay. There's a word for this. They call this, the machine is malfunctioning. That means it's not behaving like a function. They actually stole that term from algebra. All the stores in the world, you're welcome. We math people will expect our check in the mail for using our term. Malfunctioning means if you plug the same thing in repeatedly and you get different answers, that's not right. It's not a function. Does that make sense? What makes a function not a function? Now we can look at the book. The only way you can tell if something is malfunctioning is if you repeat the input. Like, you tell me, would this be good or bad? Here's X and Y. Item number 1, item number 2, item number 3. And this is like $4, $5, $6. Is there anything wrong with that? No. You got 3 different items, they can have 3 different prices. Could you have 3 different items with the same price? This is good, by the way, this is a function. A nice function. Try this. Item number 1, item number 2, item number 3. $1, $1, $1. Is anything wrong with that?
Well, no, actually no. So
No, as a matter of fact, guess what store we're probably in?
$1 store.
Yeah, Dollar Tree, or something like that. Everything's $1. There's nothing wrong with having 3 different items at the same price. This could be a screwdriver, this could be a, pack of batteries, and this could be like a, rubber bands, who knows. But here, this is bad. If you plug the same thing in more than once, you better get the same answer more than once. So look at number 12. See something wrong?
Yes.
Where?
9.
The 9. The 9 gave you 2 different prices. Item number 9, and maybe it's a socket wrench or something. The first time it says it's $5, the second time it says it's $4. Now, some smarty pants people might say, hey, maybe it's on sale. Yeah, but the computer registers it as a different item number, if that's true. If you scan something on sale, that's like item number 10 instead of item number 9. The computer, otherwise the computer will scan the exact same price. Does that make sense? How about number 10? Would that be a function? Yeah, there's absolutely nothing wrong. They didn't even repeat. If you didn't repeat the input, there's no way to tell if it's malfunctioning. So it's kind of like in the United States court system, innocent until proven guilty. So the only one that got proven guilty is number 12. Number 13, it says make an input-output table that's like these, X and Y. And it says use 0, 1, 2, and 3 as the domain. Tell me what that means. What's the
1, 2,
domain?
and 3 would be X.
Yeah, the X's, the inputs. And then you find the outputs. That's all they're asking you to do on that. Do you understand this? Make an input-output table for 19 through 24. It's a little more complicated, but they're just saying use 1, 1.5, 3, 4.5, and 6. So it might take a little while to get that thing rolling. How many did I actually give you on those? 10 through 18, and then 30 through 32. Oh, that's actually not that much. Okay, 30 through 32. Try your best on that. Don't stay up forever, doing this. If you get stuck, just bring it to class. But 33 up to 31, 32, they gave you a formula. C equals 5 plus 1.25n. Can anybody guess what the input variable would be? C or n? Just looking at it, just what's your hunch? Which letter looks like they're wanting to plug in? Do you see, it's down where it says drive-in movie? Down at the bottom of 50? C is equal to 5 plus 1.25n. Which one would be easier to plug in and calculate? N. Because you notice n is times 1.25 and then plus 5. In other words, the side where the action is, that's the input. C looks like that's the answer. C is the answer, so n is the input, C is the output. They want you to make a table of inputs, which in this case is n, and outputs, which in this case is C. Make sense? All right. Don't have a heck of a lot of time. It'll be 5 minutes. Go ahead and jump into this. It is homework 1H as in Herald. That'll be due Monday. We did a bunch of them on the first page. So 10 through 18, you can probably do really fast. So Monday, homework 1H. I'll write that up here as well. So homework 1H due Monday. And there's probably going to be a test next week. I'll tell you for sure when next week. We are going to have a practice test. I usually do that. So we're going to do the homework on Monday. I go through it. Then probably on Tuesday, we're going to have the practice test. That means for the whole hour, we sit in here, we do a test that looks a lot like the real test. Then Wednesday, we go over that, go over any answers, make sure everybody understands what's going on. And then I think Thursday, unless something goofy happens with the schedule, Thursday is gonna be the chapter 1 test. So, and the test will look very, very much like the practice test, so there should be no surprises. So if you see what's on the practice test and get familiar with it, you'll know pretty much exactly what to do on the real test. Good deal. All right.
Can I
Nice.
stop this?
What's that? Yes, oh yes, and for those of you watching at home, cheerio, have fun, talk to you later.